Jack and Jill drove in separate cars to their favorite hill, leaving from the same place at the same time. Jill drove 20% faster than Jack and arrived half an hour earlier. How many hours did Jack drive? So, to start with, we assume that the distance between the start and the end point is d for both of them because they uh, are leaving from the same place and they reach the same place. So it's the distance we assume is d. So the next thing we assume is the time taken for Jack to travel that distance is t, and the time taken for Jill to travel the same distance is t1. The time is in hours, of course. And you see, when they have given that Jill drove 20% faster than Jack, the 20% faster is the speed they're talking of. So we work out the speed. So Jack's speed is d out of t, and Jill's speed is d out of t1. Now, the 20% faster than Jack's speed will mean that it's 1.2 times d out of t. So I got 1.2 by because 20%, so 20% faster, 20% more. So if you do 100 plus 20 is 120% of what Jack's speed is. So 120% is nothing, but 120 divided by 100, that's 1.2, and that is how I got the 1.2. So 1.2 times Jack's speed is what Jill's speed is. So we can equate it that Jill's speed is d out of t1, and that is 1.2 times d out of t. And then the d gets cancelled out, and we get a relation between t and t1. So we get t equals 1.2 times t1. So the next thing to do is to note the time, because Jill arrived half an hour earlier, so they've given us the time, half an hour. So that is the difference between the time of the total time of t minus t1. So we take t minus t1 is 0.5, and then we can see that t minus 0.5 equals t1, and we substitute that. We put it as equations a and b, and if we substitute one in the other, so from a and b, we get t equals 1.2 multiplied by t minus 0.5, and in removing the brackets, we get t equals 1.2 t minus 0.6. So 1 minus 1.2 t equals minus 0.6, and from here we get t equals 3. So how many hours did Jack drive? So Jack would have driven 3 hours. That's the answer.